In this video, I'm going to go over simplifying algebraic expressions. This is something that a lot of people have trouble grasping, and it's something that you're going to need to know all throughout college algebra and for any math classes afterwards. So I have an example problem up here. Now we're just simplifying it, so there's no equal sign. We're not solving for anything. We're just going to take this mess and make it as clean as possible, complete my metaphor there. So, first of all, order of operations, parentheses first, right? You'd think, oh, we could combine the addition problems in here, but we can't because there's an x there that is not there. The 2 does not share the x with the 3, so you can't just add 2 plus 3 and get 5x. No, because the 3 is being multiplied by a variable number and the 2 isn't. So it's a complete mismatch, if you know what I mean. And same thing here. We cannot combine an x with an x squared because even though it's still x, it's squared. It's a completely different number. Let's see, x is 2, then that would be 2, and that would be 4. Completely different number. So, first of all, distributive property, multiply 4x times 2 and 4x times 3x. So bring the 9x down, and we'll do that. 4 times 2, 8x. 4x times 2. Oh, there's an x. Let's see. But we can't just add 8x plus 3 because we got to do the distributive property first. So 4x times 3x would be 12x squared because that's x times x, right? That's x squared. Still can't combine those two, but look, we can combine that later. First, let's do this. Distributive property again. So this time it's a -4. Remember, it's negative. -4 times 2x, -8x. -4 times 3x squared minus 12x squared. All right, now we combine like terms. Like terms are things that share a common factor, the factor being the x. So there's 3 terms with an x in it, and the other factor being the x squared. So then there's 2 terms with an x squared in there. And what I like to do is maybe use a different way to underline things. Oh, maybe just a double underline for those terms that can combine, right? Let's do the x squared first. 12x squared minus 12x squared. That's just 0, right? 12 minus 12 is 0. 0 times x, 0 times anything is just 0, right? So that's just canceled out. So we could just cross them off. We could add 9 plus 8x first and get 17x minus 8x. 17 minus 8, 9x. And there's your answer. That's the expression simplified. Now, just in case you missed it. Why can we combine these two numbers? Because they have a common factor. As we'll go on in later in lessons, we'll go over factoring. You can factor out an x. It's a common factor. It's like the opposite of the distributive property we did up here, you know. And the common factor here is x. You could actually say x times 17 minus 8. And that's why we can combine them, because 17 minus 8 is 9. 9 times x is, guess what? 9x. So just a little explanation there of why like terms works. Some people might make the mistake of like x minus x is 0. No. 12 minus 12 is 0. And that's not what we're doing here. We're subtracting 17 minus 8. See, if x was 2 again, it would be 18, but it would be 17 times 2 minus 8 times 2, which is what, 34 minus 16. Yeah, 18, I think. Check me on that. But yeah, that's how that works. I have one more example. Now, you don't always have x. Sometimes you get other letters to use as variables. It's the same kind of thing. Whoa, that's a lot of variables. Okay. Let's start how we started last time. Let's just do the distributive property to get rid of all the parentheses. So 5 over t times 2, 5 over t times minus x. 5 times 2 is 10. It's really 2 over 1. So if t times 1 is just t. That's why it's just still a fraction. 5 times minus x is negative 5x. It's still over 1, so get that t there. Okay. Let me just clean that up. My handwriting can be bad sometimes. Minus negative 3 times x over t. Negative 3x over t. Negative 3 times negative x. Positive 3x. Okay. Whoa. Which are the common factors now? Common factors are which terms, this is a term, has the same variables on it. So there's 3 terms with a t in the denominator, but there's only 1 term that only has the t in the denominator. So this 10 over t, that stays the same. It can't be combined with anything. This 3x, well, we have some other things with x in it, but these also have that t in the denominator, so that 3x can't be combined with anything either. So the only terms we can combine are these two, because they have x over t in common. They have to be exactly matching with the variables, right? The coefficients, the numbers in front of the variables, those can be whatever. So we have negative 5 minus 3. Negative minus the negative is actually kind of like adding it. So it's actually like 5 plus 3, which is 8. Just remember that it's negative x over t. Because when you're subtracting or adding fractions, the denominator stays the same, and the common factor stays the same as well, like we just learned. And that was the only term we could combine. This and that and it is all different. So sometimes your answers can be really long like that. 10 over t minus 8x plus 3x. That's your final answer. Now, we can clean it up a little bit. Since these have a common denominator, you can actually do this, 10 minus 8x all over t. Just make sure when you write that your fraction line is really long. And you can even go further. You can rewrite that. You can multiply this by t over t. It's just multiplying it by 1. Doesn't change it at all. And you can make the whole thing a fraction. 10 minus 8x plus 3xt all over t. 1, 2, 3 different answers. Three different ways of writing that answer, but they're all correct. Sometimes your answers can be this messy looking. Doesn't mean it's wrong. But you should always check, double check, just to make sure it's all simplified out correctly.